All right, let's get to it. I'll record this for Ellie. If this takes any longer than like 10 minutes, just cut me off and tell me shut up for goodness sake. So today is the third, and we're going to be learning about variation, direct and inverse variation. So I had some thoughts drawn up, things I was going to talk to you about. And if you're interested in wanting to know what makes something a direct variation, as opposed to, is this an example of a direct variation, or why is this and why is this not? Then that would have been the aforementioned longer version of this lecture. So bottom line is that variables in math can vary with each other directly or indirectly. By the way, another word for inverse variation is indirect variation. So I will call it, I might flip flop back and forth, but generally I'm going to try to stick to inverse because that's what you're going to see it mostly as. So if I say indirect variation, then I'm talking about inverse variation. So if two variables vary directly with each other, then it means that they are always in proportion with each other. In other words, well, it looks like this. I'm going to not give the long one. I got to cut myself off. A direct variation equation will always look like this. So it's a line that goes through the origin. To be a direct variation, you must pass through the point 0, 0, and your x and y values must maintain constant proportionality. K has a name. K is what we call the constant of variation. Okay. On the other side of things, if you have an inverse variation, then two variables, they vary with each other, but in an inverse relationship. And the inverse relationship essentially implies that whatever one does, the other does the opposite. So in a direct variation, if x gets bigger, then y proportionally matches it. In an inverse or indirect variation, if x gets bigger, y then gets absolute value wise smaller. So the way this equation looks for an inverse or indirect variation is y equals k, but divided by x. And again, k is still there, and k is still called the constant of variation. Okay. So you're going to see four kinds of problems today. This, if you're lost already, it's okay because this giving you the short version like this, it's good but bad in that it's just going to come at you and go, what the heck just happened? But once you see how to utilize it, it's not bad at all. So I'm going to flip over here soon to Delta Math just to pull up some examples. I mean, I guess I have some on my note card, but I just want to show you what it's going to look like. And like I said, there's four kinds of problems. So you're going to see direct variation without word problem, like they're just math problems. You'll see inverse, no word problems, and then you'll see both direct and inverse with word problems. And the word problem is more obviously what we want to guide you towards, but I thought you could use the practice on just the non-word problemy types. So let me get over to Delta and I'll show you what this looks like. And then we can just use Delta for our examples for our notes, if I can get it to stop doing that. So first off, here are some direct variation problems. Then this is, I know I said no word problems, but I mean, you almost can't escape just some basic words. And so the way the lingo, can you read that, by the way? Is that okay? You see it? Okay. So if x and y are in direct proportion and y is 4 when x is 6, find y when x is 15. So first off, you want to pay attention to the fact that it's a direct variation. So to be in direct proportion means that these variables are part of a direct variation. And so what this means is we're working with the equation y equals kx. Basically, you're just going to keep fluctuating throughout the day between y equals k times x and y equals k over x. And what it really becomes, essentially, every problem is I need to find K, and then I need to backtrack and find Y or X, depending on which one I know. So like in this problem, we'll be given one relationship that's going to enable us to solve for K. So they tell us that X and Y are in direct proportion. Y is 4 when X is equal to 6. So that means that I can change Y into 4. and I can change x into 6. And I could have written 6k there. I just chose to do it like that. Still good? And then all we have to do is solve for k, the constant of variation. Some people call it the constant of proportionality, by the way. So if you ever see it called the constant of proportionality, same. So if I solve for k, I should get k equals 4 divided by 6, which is also known as 2/3. Any questions on that? What it means is that this particular direct variation, this particular example, subscribes, bless you, to this direct variation, y equals 2/3 of x. And that's because we found k. K is the constant of proportionality. So having established that relationship is the key. And now all you have to do is use that relationship to figure out another, input-output situation. So like in this case, someone tells us to find y when x is equal to 15. So all you have to do is what you've always done since you were a youngin', and that is if someone gives you one of them, which they are, they're telling you that x is 15, you just plug it into that equation that you just built and do a little bit of basic math. So the purple equation on the right is just going to change to now say y equals 2/3 times 15. What does 2/3 of 15 equal? 10. Very good. And so your answer is just 10. So you go down there and just type 10 in the box. Okay, so that's an example of a direct variation problem. There's no fluff. There's no talk about water pressure and dog food and stuff. It's all just boom, to the point. They'll tell you, here's the direct proportion. Here's an x and y value that are in this proportion. And then I'm going to give you one, you solve for the other. It's very repetitive. Let's take a look at an inverse one. So here's an inverse variation example. So the moment you see that the problem, by the way, these will all be mixed together. So like the sections are, there's a section of these and a section of word problems. They're not mixed in that sense, but they'll be mixed in the sense that you might get 1 direct and then 3 indirect and then 2 direct and then 3 indirect. So just they're going to match you randomly. But anyways, the key is you've got to read somewhere to figure out which equation you're working with. And because it's an inverse proportion, then we know we're going to work with, what's that equation for inverse? K over x, right? So the inverse is this one. So you just write that out every time. Just write it out. And then they're going to give you one relationship or I think I'm saying that the right way. One pair of numbers that is inside the relationship. And they're going to tell you that the square of Q. Ooh, I better fix that. P is, oh my gosh, we got to fix this. I didn't see this one coming. Are you guys excited or what? I didn't see that. So we have to change this to K over X squared. My bad. Because I didn't see the square. Ooh, and P is 22 and Q is 8. And so, by the way, you kind of have to read and kind of pay attention to the order of things, but it says P is inversely proportional to the square of Q. So that's why it goes like this. And by the way, if you'd like to make it a little bit better, a little bit more delicious, you can go like this. P is inversely proportional to the square of Q, like that. So you can use Y's and X's all the time as long as you match them up. It's all good. All right, so they're going to give us one relationship, one pair. So P is 22 when Q is 8. And what is 8 squared? 64. Good. You're going to get a lot of big constants of variation when you're doing inverse variations because of the nature of how we set these up. So to solve this equation for K, we're going to get K equals what? What is 22 times 64? Gotcha, 1,408. So that means that our equation looks like this. The one like we're going to model after is going to be y equals, sorry, I keep doing y. Sorry, that was old man groan. That's my bad. So I'm going to write P equals 1,408 divided by Q squared like this. And then all we got to do is solve. So they're going to give us something. So they say to determine the value of P when Q is equal to 4. So again, you just take 4 and stick it right there. Whoop. And what's 4 squared? 16. So you're just going to go with P equals 1,408 divided by 4 squared is 16. And then using your calc, do you like that? You get 88. So far, so good. These, once you get into this and start doing them, you'll realize this is a total breeze. The key is to pay attention just to the verbiage and watch out for the words direct or inverse. What? What's the matter? What? God damn. Okay, I'm going faster. So that was for me. Was that for me? So harsh. Okay, so here's what the word problems look like. Direct variation word problem. Trying. I figured you were talking to Josie or something like that. So we know that we're working with a direct variation. So the number of miles driven by Alejandro varies directly. So we have to work with the equation y equals kx. And you can use different variables, of course, by the way, too. So no problem at all. So the number of miles driven varies directly. So you would just want to pick one of these pairs because what we're trying to solve for is the constant of proportionality here. And the question logically that someone would ask is, couldn't I just divide them? And the answer is, well, of course, that's what you wind up doing anyway. So which one do you guys want to pick? The first one, the second, or the third? Third, says, oh, crazy one over here. Okay, so third. Fair enough. So we're going to do the third one. And what we're just, again, trying to find is K, the constant of proportionality here. So we're going to take the 645 and put it in place of the number of miles driven. And then we're going to leave K alone, and then we're going to put 25 here. And again, it just boils down to division like your intuition would have told you. So if you take 645 and divide it by 25, which you would have done anyways, you get K equals 25.8. What does that mean? What does that number in this context mean? You guys are all smart people. What does that number represent in this word problem? Miles per gallon, right? You've been understanding that since you were quite young. So miles per gallon is just distance divided by what would that be? Whatever, something like that. Anyhow, so that's my K value. So we're just going to take 25.8 and we're going to multiply it by 39. And that's that. So that's
It'd be the distance you drove divided by how many gallons you spent.
right. That must be like I don't know why I'm using the term rate because it really doesn't have anything to do with rate, does it? Not rate as a time, but
You're the one with the colors.
rate of fuel consumption, not rate of speed. Take that. And then do you want to see an inverse one or do you want me to shut up? That's just say again. An inverse? We're doing it. Oh yeah.
Only one person said no.
Nice. So for a given set of rectangles, the length varies inversely with the width. And so the length is going to, and this time I'm not going to use X and Y. I don't want to make anybody cranky, myself included. So I'm going to say that the length varies inversely with the width. Okay, and that's just for this particular given set of rectangles. That's not like generally speaking true about rectangles. So in one of these rectangles, the length is 2 and the width. By the way, does anyone have any issues with just setting up that equation? Like since it's inverse, we know to pick this one. Okay, and then they're just going to give us one relationship. Without that, we wouldn't have enough to go on. But they do tell us that in one of the rectangles, the length is 2. So our equation is going to be 2 equals K divided by, and they tell us that the width is 18, like this. Good. How are we going to find K? Multiply both sides by 18. So what's K? 36. So our constant of variation in this case is 36. So what would my equation look like? The one, like if I said, write your variation equation, write your inverse variation, what would it be?
2 equals 36.
No, no twos, no.
It'd be 12 equals 36.
No. It would be this equation right here with K changed out to 36. Try it again, Blair. There you go.
I'll skip it.
So that's a really important part of this is just to get in there, find K, and then rewrite the problem. Basically, just rewrite it, but with an actual numerical value for K. So this is the indirect variation that we want, and then we can use it to answer any question. So it says, calculate the width of a rectangle whose length is 12. All right, so now we're going and actually getting the problem done. So we have our little equation built, and we're going to put L in as 12. So the 12 is going to go right there. And it's going to say 12 equals 36 divided by W, like that. Does that look correct?
Mhm.
Nice. Okay. And then how would we solve it from here?
You divide 36 by 12.
No, be careful. This is some different algebra. We need to multiply both sides by W because the W's on the bottom, right? So we're going to multiply first by W like this, and we're going to get 12W equals 36. And now what do we do?
Divide.
Now we divide and we get W equals 3. Got it? So that was as fast as I could go. And even that was like 20 minutes. I'm so sorry. 20 plus. I can't. Oh, the answer, you could just put 3. Yep. Good question. You'll know. I mean, Delta will bark at you if you're not right, but that's that. Sorry, that was so half-hearted, but God, imagine how bad the long one would have been. So, yep, it's on Delta Math. It'll say assignment number 32, maybe. And then you people that get to do quiz corrections, I'm going to hand those back out. So